Solving equations. When you solve equations, there are two types of solutions. One known as general solutions. General solutions. The other one known as exact value and approximate. Okay? There we go. General solutions. The exact value and the approximate, they have values like pi, 3 pi over 2, 2.06. Usually, though, all the answers are always in radians. Okay? So these go with the unit circle / calculator. Oh, sorry, no slash there. Unit circle / calculator. That's where these solutions come from. The other solutions come from the functions. The functions include all solutions. If you remember, the following graphs had periods of 2 pi. Sine, cosine, cosecant, and secant all had periods of 2 pi. That meant the graph repeated every 2 pi radians, and the solutions went on and on and on. So for instance, if I take pi from this side and I'm applying it to a general solution problem, you'll be able to tell by the question how it's phrased. Pi would be this point, and sine would be right here. Well, pi would be an answer. 3 pi would be an answer. If I kept going, 5 pi would be an answer, so on and so forth. So usually you add your counters to any general solution. So you take this angle, pi, and you add the period 2 pi n, where n stands for an integer. Okay?
How far do you go up?
No, that works for all infinity. Okay?
No, I don't want to go to infinity. Though.
No, that's how you write it. Pi plus 2 pi n. See, when n is 0, you get pi. When n is 1, you get 3 pi. When n is 2, you get 5 pi. So n is any integer. It's important you see that because I just uploaded the student solutions, so I haven't linked them yet, but I did that today during my free period. So you're going to see plus 2 pi n, you want to know what that's for. That's for all solutions, usually because there's an infinite number of solutions. Okay? So there's two types where you just answer. Sometimes you have to use generals, like call them generals. Sometimes you have to use generals to find all the exact values, but that's not for a couple chapters away. So for instance, pretty easy. Let's see, unless specified, the solution should be an exact value radian form. Got it? As you encircle trig identities, algebraic operations, solve the problem. Yeah, we're good to go. Find all solutions of the equations. As soon as you read that, that means you're going to have counters associated with your answers. Cosine of t. All answers mean you're looking at a graph like this of cosine. So, integers are positive or negative whole numbers, aren't they? Somebody goes, can I just type it in my calculator? Well, yeah, but that's not going to help you read what's going on. Instead, on this one, I said you're going to use a unit circle or your calculator to start the problem. And then you're going to use that to help you answer the question. So on the unit circle, where's cosine equal -1 at? Pi. So here, t equals pi. Not that difficult. If I take a look at my solutions, there. At pi, the cosine is equal to -1 because it's the x-coordinate, correct? And it's also going to be true where at? Where else? 3 pi. It's also going to be true on 5 pi. It's also true at -pi. And it's also true at -3 pi. And as Rachel just said, you don't want to write all those answers, but if you write pi plus 2 pi n equals t, that is all the solutions. Because n can be any integer, positive or negative. If you want to say n is 7, then that means 15 pi works. If you want to say n is -1, that means negative pi works. N is -2, -3 pi works. They all work as answers. You've never written your answers in terms of general solutions. You've always been able to have one answer or a couple answers. That's fine. But this is because sine, cosine, secant, cosecant, tangent, cotangent all have repeating periods of the graph. Okay? So there's an infinite number of solutions. I guess you did do inequalities, like x is greater than 2, but you didn't really write it as a general solution. You just wrote it as an inequality. All right? So you need all that for the right answer. Okay? All right, we're moving on. Kaylee's ready to move on. Let's move on. So, the cosine of x equals negative pi over 3.
Yep. 5 power. Wait, never mind. Fine.
Okay, can you use the unit circle for this? You have a place where the x coordinate will equal negative pi over 3. Negative pi over 3, comma y. You have that somewhere?
No.
No, you don't. So that's out. I said you can use your calculator. Get an idea, get a start. What is the inverse of negative pi over 3? Everybody looks at their calculators just like it's a paperweight. It actually works, and you can do some things with it. Yeah, it is. What do you get when you type that out? Well, you can graph it too if you like.
Nah.
If you want to graph it, you'd put y, domain error. What's up with that? You don't know? Radians.
Oh, my bad.
This isn't looking well for the home team.
Yes.
Yeah, what does that mean? That means no solutions.
Oh. Well, that's nice.
Well, why aren't there any solutions? Because calculator said so. Yeah, but the calculator is written by somebody. You're somebody else. You should be able to figure it out. Pi is equal to what? 3.14. The cosine of x has to be between 1 and -1. If you take 3 into pi, that's going to be bigger than -1, or have a bigger absolute value. It's actually smaller. If you wanted to put on your graph, you can put cosine of x plus pi over 3, and it will never cross the x-axis. It will never equal 0. X-axis. So these are basically like, you have a lot of options in front of you to figure these out. Try all of them if you have to. Yeah?
For all the, tangent, sine, or whatever.
Tangents has a period of pi for tangent.
But are they all between -1 and 1?
No. Only sine and cosine are between -1 and 1. Okay? Cosecant and secant don't live between -1 and 1 because they're reciprocals.
Oh.
You'll get a lot of experience this week on this. Oh! Cosecant times sine equals 1. What's wrong? Yeah, no solution. Oh my gosh, how do you solve the equation cosecant times sine equals 1?
Yep.
You do.
When they equal 1.
What?
When they equal 1.
What did you say? Close. 1 equals 1. That's true for what? Close again. Close. 1 over sine.
All but something.
All but something. This is true for any theta, or is there a couple that it's not true for? True for all theta except pi, 2 pi, 0, negative pi. Remember those? So it's all true except for pi
Plus.
n. On the unit circle, there's 2 places where sine equals 0, isn't there? One of them's at 0, one of them's at pi. Correct? 1 divided by 0 is obviously a bad situation. 1 divided by 0 times 0 doesn't equal 1. They outlawed that when they decided to make 0 a number. That took a huge debate. That took like 200 years to get past that. Okay? But nevertheless, they did.
Wait, that equals 1?
No, it doesn't equal 1. So that's why it's a problem. So I can just write pi n because n can be any integer, can't it? N can be 0, -1, 1. Life's good. So theta can be anything except for pi n, which coincidentally enough is the domain of cosecant. Okay? All right.
No, not yet.
Not yet. Oh my gosh. What the heck is this? Oh, this is a hard problem.
Is it?
Yeah, it is.
It's only 12.
I'm going to pull a slick little move right here. I'm going to let, and I decided long and hard about this 30 seconds ago, that I'm going to approach all problems like this for a while. I'm going to let x equal 3 theta. Okay?
Okay.
We don't have any double, single angle identities on our note card yet. So I'm going to look at the problem like this. 2 sine of x plus square root of 2 equals 0. Okay? Yeah, but what if it would have been 2 sine of 3x plus the square root of 2 equals 0? What would you have done? Oh, easy. I would have let theta equal 3x. That's why I'm up here. All right, ready? Ready to move on? All right, we're moving on. Ready, Savannah? Exciting. How do you solve for x? Subtract square root of 2 and divide by 2, right? So sine of x equals negative square root of 2 over 2. This also allows you to concentrate and focus on isolating the variable first. If I would have kept the 3 theta in there, you'd have been so consumed by it, you wouldn't have seen what else to do. Now you're not consumed by it, you're solving. So what does x equal? What else? And 7 pi over 4. Okay? So far, so good? You ready? Now, this 3, see that says problem number 12? This is going to be a tough homework section. That's one of the reasons I want to get the student solutions up there ASAP. So now I'm going to go back to my substitution. All these problems occur the same way. If you try to do your own thing, you probably won't get the hang of it for a while. Okay? My substitution will be 3 theta equals 5 pi over 4 plus 2 pi n, and 3 theta equals 7 pi over 4 plus 2 pi n. We've already established that for sine, cosine, the period is 2 pi, and those values will repeat every 2 pi radians. Okay? So they repeat. The question said solve for theta. And find all solutions, I think. I don't know, does anybody have the book open? Is it still finding all solutions? Okay. So, how do I divide by, or how do I solve for theta? Now look at this. Theta equals 5 pi over 12 plus 2 pi over 3n. Theta equals 7 pi over 12 plus 2 pi over 3n. If you think you can wing that on your own and get those solutions, fantastic. If not, this step-by-step way of doing it works every single time. This is the first year I've written it like this in a top-down fashion. Before I've done 3 columns, I decided this year I'm going to top-down. Okay? Just because the difficulty of the problems has increased a lot. So those are your solutions. And you're going to say, that doesn't look like solutions. Well, they are solutions because I've written a lot of computer programs. That's how you write a loop. You have something with a variable in it. They keep putting numbers into it to generate all these solutions. Okay? Nice. I'm ready. Ready to try another one?
Sure.
Let's try another one. Ho,
That
ho.
doesn't look that hard.
Brain break. Who said?
The last one was harder than
Last one was harder than this. Oh, do you guys want to try this on your own?
this. No.
What?
I didn't say that.
Does anybody know what the first thing I'm going to do is?
Let theta equal x.
Yeah, I'm going to say, you know what? Oh, see, there you go. Went off on your own, ran the wrong way. Let theta equal x minus pi over 3.
Oh.
This is by far, hopefully, the best way of doing this.
Oh my heavens.
Cosine theta equals -1. Yeah. So theta equals pi.
That's 2 pi over.
So I'm going to make my substitution. I'm going to say that x minus pi over 3 equals pi plus 2 pi n. What about negative pi? It's in there. If n equals -1, it's in there. What about 0? That's where cosine equals 1, not -1. Yeah, actually, you all sound like that when it comes, Not one at a time you don't. One at a time you all have individual voices, but when 2 or 3 are talking at once, that's what it sounds like.
We haven't done that all year.
Just 15 minutes ago. You had a story going on, they had a story going on, somebody come in and, oh, yeah. All right. So, how do you solve this now?
Add pi over 3.
Fantastic. Pi plus pi over 3 is obviously 4 pi over 3 plus 2 pi n. If you want, you can put numbers in and check the original problem, see if it works. Very quickly, no. Okay. All right. It is. The brain break that came up today is not a very fun one. In fact, there's been people saying it out. It's not, I said I wasn't going to go out of order. I kept true to that. Okay?
Okay.
Do you want to see what it is?
Yeah.
Do I regret them? No. I'll find out this spring when the ACT rolls around. Here we go. Here we go. Here we go. Here we go. Oh, I hit the wrong one. What the heck? There we go. Here we go.
Oh my gosh, why don't you just have a brain break thingy?
I do.
But
But then somebody will say, oh, I don't believe you. I don't think that's the one you did today. You're just making it up. I've been around this long enough. So, here's a brain break I did for today.
that looks like a lesson.
It is a lesson. The brain break is in the lesson. Oh, wait a minute. I'm wearing
Why are you saying that to somebody? I was like,
Ralph Lauren or whatever that is. Where'd it go? You see it out there? Here it is. All right, figure eights. Stand up. Find a piece of paper. I told you I was starting at the very beginning. It wasn't skipping any. So, find a piece of paper. No, we did the menu one. This one is just find a piece of paper. Stand up. Grab the paper with your right hand. Now pass the paper around your legs in a figure eight pattern. Yeah, we have. You'll have to grab or release the paper each time around your leg and do it as fast as you can. I predict Alex would get beat by Sam. Alex is impressed he didn't think of that move first. Then change directions. And see, I don't understand this one. All right, good. What? No. All right, extend this. Take one piece of paper in each hand. Oh, each hand. Try that. We've never had anybody do that successfully. Sam will do it successfully, I have no doubt. Oh, wait. I'd go for it. Okay, try it. One in each hand. So you have two pieces of paper going. See? He's good. Stephanie says I'm not trying that at all. All right. Anyway, that's our brain break for today. Thank you very much. All right. See? I'm willing to give it a shot. I like the two pieces of paper. That's good. 2 cosine squared plus sine of x equals what?
It's starting to sound like like you did before.
Yeah. I'm sorry. Is there a problem you want to do in between 16 and 36? Pick one. How about 24? 24. What does it say? What's 24 say?
2 cosine of x equals square root of 3.
Okay. 2 cosine of x equals square root of 3.
So don't you just divide?
You do divide. Cosine of x equals square root of 3 over 2. Probably why I didn't pick any problems with that stretch. And what does x equal?
11 pi over 6.
11 pi over 6. And what else? Pi over 3?
6.
Pi over 6. So to answer all solutions, that's just the unit circle. To answer all solutions, you write 11 pi over 6 plus 2 pi n. And you write pi over 6 plus 2 pi n. There's no way to group 11 pi over 6 and pi over 6 as one equation. Sometimes you can, sometimes you can't. But there are lots of ways of writing these answers. Okay, the main thing is you don't have degrees. These are all real numbers. All right. Now we'll go to the next one. Probably, I don't know, this one take just a little bit of time. I'll let you write it down for just a minute, and then I'll let you think about it for 30 seconds after that. Oh, remind me, another story about what I was talking about earlier with the basketball.
Right now.
No, I shouldn't. I should wait till the mic's off.
Oh.
2 cosine squared plus sine of x equals 1. So,
Did you ever watch that video?
Ms. Ballard, do you have any ideas?
Nope.
You have no idea.
No. Are you really talking to me? Divide by 2.
You can divide by 2 if you want to. Cosine squared of x plus 1/2 sine of x equals 1/2. You can do that.
Is it this one?
I wouldn't do that. That's okay.
Let's not do it.
Yeah? Absolutely. You can change the cosine squared to 1 minus sine squared.
Oh.
To 1 minus sine squared of x. In fact, this move,
That's funny.
you'll see this problem probably 15 to 25 times if you stick around this class in calculus. So this is a classic problem that you always have to do. Sine squared of x plus sine of x equals 1.
I should have some other video right now.
No. All right. So the problem is, how do you solve this? And everybody in the room knows, but you have to think about it as if it were written this way. 2 minus 2y squared plus y equals 1. Yeah, you have to factor it. So I'll get it all set up. 2 sine squared of x minus sine of x minus 1 equals 0. Now that you have this, yeah, you can factor it, attempt to factor it.
Yeah.
And obviously with the quadratic in algebra, you know there's going to be 2 solutions. Usually in trig, if you have a quadratic, that's going to mean 4 solutions. Usually, but not always. And in this case, you have sine of x minus 1, I believe. So now you have 2 problems for the price of 1. Where does sine of x equal negative 1/2 at? And where does sine of x equal 1 at? Because it does equal 0. So anytime you see a squared, you think Pythagorean identity.
Pi over 2.
Yeah, pi over 2 for this one. So here, x will equal pi over 2 plus 2 pi n. Over here,
11 pi over 6.
x will equal 11 pi over 6 is one of them. And 7 pi over 6 for the other one. All right? So, use identities, use your algebra. You're getting very close to solving problems involving both algebra and trig expressions. That's what this is leading you up to, solving the big-time problems that are faced in calculus. Okay? So, go ahead and do page whatever, 1 through 35 odd.
All right, take whatever.
We'll finish it up tomorrow with a 10 for 10, and we'll have another 10 for 10 on Friday. It's 489, I believe, isn't it? 479, sorry. 479. You'll need your note card this week, and because we're going to add a bunch of identities to it on Thursday. I realize that some of you might be gone on Thursday, but I'll try to put the video up there and make sure you get the identities from somebody else. Signing off.